particularly early in the sort of 90s and 2000s when sports science started to have a real big research boom. Women were left out and left behind, and I think that is changing, but historically that has been the case.
In this episode of Fueling Greatness, I interviewed Dr. Alannah McKay from Australian Catholic University, where she's a postdoctoral researcher. The topic we got into was nutritional considerations for female athletes.
We all have muscles, we all have a heart, we all have a brain. They work to produce the same output and do the same thing, but there are slight differences that when we're coming to particularly elite sport and the high-end level, it's worth noting that males and females are different, and whether it's as simplistically as their body size or physiologically in depth as their hormone fluctuations, they are different. There is no evidence at this point to suggest that we need to be tailoring our diets differently for men and women, and even less evidence that it should be different for the menstrual cycle.
So welcome to Fueling Greatness, Dr. Alannah McKay. It's so good to talk to you. We were just talking offline there about this, this thing about being at different time zones. And that's what I find amazing about this opportunity to speak to people who aren't just a wealth of knowledge and information, but also from all over the planet, which is interesting to see how expertise is distributed across the planet. But one reason why I've stretched all the way to Australia, Alannah, is because the topic I want to get into today is really about females and female athletes and nutritional considerations and such. And I can't wait to have this chat with you. But therein lies the challenge to me. There are very few people who can talk about this stuff. So I'm going to want to dig into that soon as to why that is, given roughly half the planet are females. So before we get into this conversation, why don't you give us a bit of an overview as to who you are?
Yeah. So firstly, thank you for the invitation to come have a chat. That's always really good. My name's Dr. Alannah McKay. I have a bachelor in sports science and exercise science. So started off more in the physiology, sports science realm. I did some time at the Australian Institute of Sport, where I did my PhD there, and also did my PhD with the West Australian Institute of Sport, really looking at dietary strategies that can affect iron metabolism and the immune system. And this is when I sort of started to move a little bit more into the nutrition side of things. And when I finished my PhD, I went straight into the role I'm in now, which is as a postdoctoral research fellow at the Mary MacKillop Institute for Health Research at Australian Catholic University. So here my supervisor is Louise Burke, who is the go-to sports nutrition. So I've moved much more into sports nutrition since being with her, which has been really interesting. And really my specialties around iron metabolism and athletes, and particularly now female athletes, but also really interested in other areas of female physiology, nutrition, and some other micronutrients we're starting to look at as well.
Fantastic. So I've got the right person for this conversation today, Alannah.
Rippling.
Yeah. I mean, look, you're very lucky to have Louise Burke, Professor Louise Burke, as your mentor. I mean, there isn't anyone who's at least a sports nutrition or sports science professional who hasn't heard of Louise. So that's amazing. So you have gone beyond your PhD though, Alannah. So you've already spent a long time getting to where you're at and all the trials and tribulations of getting your doctorate. And I feel one's pain in that regard, because it is an incredibly hard achievement to get. But you didn't stop there. Why is that? Why did you go on and do a postdoc?
That's a great question. You know what? It was because Louise Burke asked me to.
Whatever Louise asks, she gets.
Yeah. No, she wasn't my PhD supervisor. I had a really great supervisor in Professor Pete Peeling, and he got me so excited about this area of iron metabolism. And I just enjoyed doing research with him so much. And during my PhD, I also got to work with Louise while at the Institute of Sport, and the way she operates is just incredible for people that have not only got to meet her and talk about research, but in terms of having a boss, there's not many better bosses you could ask for. So when the postdoc opportunity came up, I thought it's not only going to be a way that I can keep doing all the iron research I'm interested in, but also branch out and learn from somebody that's just had an incredible career and is still having an incredible career.
Yeah, well, I mean, the amount of impact that she has had, and Pete Peeling, who I've interviewed them both before on my old We Do Science podcast, and hope to have both of them back at some point on this one, now that we're mentioning their names. But listen, I mentioned this in most podcasts, or at least I will be, given this is a pretty new podcast so far. But I'm going out of my way to try and interview people on topics where I feel they genuinely have appropriate, relevant expertise. There's an awful lot of information that exists out there, whether it's Google, influencers, or as discussed in several previous podcasts that I've now recorded for Fueling Greatness, this problem where there is increasing amounts of research in a variety of publications, but it's more of a quantity versus or lack of quality issue. But one thing that comes up more than any other is the fact that almost all this research is done on males, not just males, but young males. So there's problems there that I want to tease out with you as it relates to females, because we're going to talk about women, females. We can define what we mean by all that in a minute. But just generally this idea of how we come to learn about something through the research process, and then how do we translate that into application into the real world, because ultimately it's all very well having these chats about science and rocket science and nutrition and mechanisms and all that stuff. But is it actually relevant and practical to real people in the real world? And by that, what we're specifically focusing on here is athletes, professional athletes, elite athletes, recreational athletes, people going to the gym, people exercising for health, performance, body composition, that sort of segment of people who will be listening to this podcast. So let's dive into the first topic then, which is we're using phrases like males and females. And male, female is very popular generally in the news right now for various reasons, but specifically when it comes to things like sports nutrition and sports science, as I said, a lot of knowledge, a lot of the body of knowledge that exists out there has been sort of regardless of gender. So let's have you first just walk us into this concept of what is actually a female. It sounds like a ridiculous question, doesn't it? What is a female, Alannah?
Oh, there's a can of worms you might be opening there. But it's important to note that we have gender constructs and we have biological constructs. And really what I'm talking about today and anything that I'm going to do research-based is around the biological constructs. So really looking at sexes, and in that we talk about males and females. And the differentiating factor here is really around those sex steroid hormones. So in males, we have testosterone circulating, which is the hormone that drives a lot of the reproductive function in males. And in females, we have very low levels of testosterone, but we primarily have estrogen and progesterone that circulate. In males, that testosterone is relatively stable across the lifespan. After puberty, it does decline, but very, relatively stable. Particularly when you compare that to females who have cyclical changes in those ovarian sex hormones, with estrogen and progesterone not only changing on sort of a monthly cycle base, but also significantly across the lifespan as well.
And beyond gender, there are some complexities to this, some nuances, as is always the case. But we also have older and younger females. We have trained and untrained females, particularly, you've mentioned hormones. We think of menstrual cycles. Then we start thinking, well, what day of the month are we even talking about here? There's huge amounts of variation, particularly when we think about females, female biology, female physiology, female biochemistry, etc., etc. Is that part of the reason you think, though, why we've just, as scientists, we've just tried to make our lives a little easier? We've just done men because there's less variation in those things?
Yeah, completely. If you look at sort of, most studies in the exercise realm will sort of recruit, I'm talking very much generalizing here, subjects that are between 18 and 35 years of age. And when you look at a male that's 18 to 35 years of age, they look remarkably similar. And that makes for a really nice science when all your test subjects are quite similar. You're going to get a nicely distributed data set, which is going to be beautiful for your statistics. But when we talk about females, those 18 to 35-year-olds can look very different. We can see states of natural menstruation and eumenoric menstrual cycles. We can see females using hormonal contraception, and within that there's another 100 types of hormonal contraception they could be taking. They may be anovulatory, they may be amenorrheic, they may have very long menstrual cycles or very short menstrual cycles, and they may even be pregnant. So there are so many different types of women, if you want to classify them as types, as well as different life stages. So we move into postmenopause at an earlier stage than what men may see these testosterone declines. So we do have much more variation in as women, and that can make research really difficult if we don't have the sample sizes that we need to look at biological effects. So I think particularly early in the sort of 90s and 2000s, when sports science started to have a real big research boom, women were left out and left behind. And I think that is changing, but historically that has been the case, as it's seen as an expensive exercise, and one that requires a lot more time and a lot more effort to control some of these factors to do the good science that we all want to do.
So I'm going to ask you a question as it relates to all this stuff initially. I'm not, hopefully this isn't a sabotaging kind of question, but one, when you look at the attributes of a human being, and then we go, well, let's flip it the other way and differentiate males and females. Do we not have more in common as human beings than we do as males or females? Or is that just overly simplistic?
No, I think you're probably right. I think we do have more in common, but I think probably the factor that we're maybe in sports science research and sports nutrition research, we're often looking for small performance effects or small effects, say, of a supplement on sports performance or a supplement on athlete health. And when we're looking for these tiny effects, the differences, although they might be small, may be clouding what we're trying to investigate. And there's, more questions around ecological validity and how applicable is it if you can't pick it up in a cohort that is slightly more variable. But generally, I think you're right. We probably do have more in common than not. We all have muscles. We all have a heart. We all have a brain. They work to produce the same output and do the same thing. But there are slight differences that when we're coming to particularly elite sport and the high-end level, we do want to sort of be able to nut out some of these effects of these supplements without some of the additional variation that these things can cause.
And I'm pleased you said that, because it's sort of a deliberately leading you into this idea that there is a hierarchy of relevance when it comes to, for example, our focus here is things like nutrition and lifestyle. And how relevant it is that we should manipulate that based on gender, for example. So flagging up right from the start there is that aspect of relevance. If you are not an elite athlete, if you are not a high level, you're not a high level recreational exerciser, then maybe factoring in your gender, for reasons that we'll get into, we'll totally unpack all of this. Maybe that's something you need to be less obsessed with. And the reason why I'm mentioning it is because you only have to look at social media and you're seeing, or Google, or the internet. There's a lot of advice and recommendations being given out there, for females who are dieting, who are, whatever they're trying to achieve. They should, eat a certain way, not eat certain foods. You hear phrases like hormone optimisation, which is one of my favorite or least favorite sort of concepts, along with things like biohacking your hormones, and, women should do this and it's important and so on. Well, maybe it isn't important, but I think largely what I want to unpack and tease out here is the evidence behind all of this, and where it's basically baloney. It's just a bunch of nonsense. Or quite simply, we just don't know yet. We actually don't know yet. Yes, an influencer might think they know, but the reality is, the science hasn't caught up with that. So maybe there's something, maybe there isn't. So let's explore a lot of that, largely around nutrition and so on, which is such a small fragment, isn't it? But what led you into studying this stuff, though? I mean, you've obviously, you've had some great mentors. You as you started, you've got this interest in human performance and nutrition and iron and so on. But how did you actually end up down this particular path?
Yeah, I think it started with my research into iron metabolism. My PhD and a lot of my research during that time was looking at factors that affect our iron regulatory responses to exercise. And a lot of my research, I'll be the first to admit, was through my PhD was conducted in men with a small number of females throughout. But then it came to sort of recruiting for different studies and realising iron deficiency is predominantly a women's problem. So in Australia, the rate of iron deficiency is still around 33% of premenopausal women generally. And in athletes, we think this is more around 35%, so a little bit higher, but it's also quite difficult to get prevalent statistics in athletes because we actually are normally caring for them and they're already supplementing and doing other things. So we do think it's higher, but it sort of was very apparent to me it is more of a women's problem in terms of iron deficiency. And looking at ways or reasons why more women are iron deficient than men was sort of where my postdoc started. And that led down sort of a hormonal route as one of the avenues that we started looking at. But understanding the complex interactions of the hormones and the female physiology led to more questions and answers, I think, in terms of how performance and training and other nutrition may be affected by female physiology.
So when we think about female physiology or female endocrinology in particular, I mean, it's always hormones. We always think about estrogen, progesterone. Indeed, in the clinical spheres, it's a big deal trying to support women as they age and the impacts that can have. I remember my own mother had terrible problems when she got into the menopause. It was really, the psychological, not just the physical, but the psychological influence of those hormonal issues was really quite prevalent. But of course, we go beyond that massive impact into these marginal areas that we've been discussing. But going back to hormones, I mean, what are these different hormones, and what is their actual impact on female physiology?
Yeah, you're completely right. We do tend to focus on hormones maybe more than we need to. We know some things about how estrogen and progesterone and testosterone all play a role in certain aspects, but I guess there's probably larger morphological and anthropometric differences that are driven by the hormones. But things like males will have higher amounts of muscle mass and bone mass, and women will have proportionally a larger amount of fat mass for their body size. We know women have smaller hearts and therefore smaller cardiac outputs compared to men. And this means inherently they're going to have a lower aerobic capacity, differences in thermoregulation, differences in substrate oxidation, all these different factors that may influence performance. And sure, some of it is going to be driven by the hormones and how they help develop our reproductive systems. And, for instance, proportion of fat mass is really going to be related to reproduction, but they are going to drive some of those issues. But when we're talking about maybe nutrition and performance interactions, sometimes it's maybe not so much the effect of estrogen per se, but maybe the lower cardiac output and therefore lower hemoglobin mass that a woman's going to have compared to a man. Or even we see more generally, they're going to have lower body masses compared to men, which may dictate differences in absolute amount of energy required to fuel that body.
There's some big areas there that I want to get into, but I think one question that I've got in my head right now is, it's sort of a chicken or the egg type conversation. Is it the hormones that are, creating the nutritional challenges, shall we say, or is it the nutritional issues that are causing the hormonal challenges? Do we know that yet? Do we know what's going on, or is it purely an interplay issue? What's happening there?
Yeah, I think it's maybe an interplay issue. I mean, we can think of conditions like low energy availability in females and males that's going to lower some of those key hormones like estrogen and progesterone, which in women leads to amenorrhea. So we know that nutrition can have a role on the hormones. Whether the hormones are having a role on the nutrition, we know, for instance, that estrogen and progesterone in their own ways may regulate iron metabolism and hepcidin concentrations in particular. So it probably is two-way. The effects are probably quite small, though, in some instances compared to others.
The thing about hormones, like lots of things that we can test for in the body, there's a huge amount of variation that occurs in any given day. And depending on when you test, you're going to get a different snapshot of what's going on. And of course, that can lead people down some interesting paths, because they'll go get a test done and, it says that they've got high cortisol, high stress hormone, in the morning, or their testosterone is too low in the morning. Because we're talking about hormones and we're talking about research that's based on testing this stuff, what are the sorts of things that we need to know about this variation of hormones, and maybe issues with the interpretation of what those findings are?
Yeah, I think particularly around female hormones, I'd probably have much more experience to talk to that in particular. But you're right, it's 100% a snapshot in time. It's a concentration-based measure that may change by the afternoon, just simply not even due to things like diurnal variations or fed or fasting like other biomarkers, something like cortisol. We know morning has diurnal variation. Hepcidin, again, 'cause I always have an iron lens, but that has diurnal variation. There are other markers that you want to be tested fasted. It doesn't look like estrogen and progesterone have that sort of effect. It's simply that they are variable and they're going to change in response to what the body's doing. So I think it does need to be interpreted as a snapshot in time. I think, we talk about phase-based testing and trying to test at different phases of the menstrual cycle. It's really quite hard to do. So understanding when your blood test is collected, what sort of hormonal profile should be expected, and whether it meets, using clinical reference ranges is probably the best way to go about it, because those ranges capture what could be expected at that time the test is taken, and that's sort of where we should go.
So I referred to this idea of hormone optimization, hormone manipulation, biohacking hormones, that sort of thing. I mean, what do you think about that concept, that thought?
Oh, gosh. I mean, I've read a lot of things on the Google about the menstrual cycle and how it can affect your training and performance. And I feel like that's one of those that I haven't dived into too thoroughly. I haven't seen any sort of scientific backing to say that we should be trying to make our hormones do certain things. There's definitely flags, when things like testosterone or estrogen are too low. They can be indicators of different clinical issues, and that needs to be treated as it needs to be treated. But I don't think we need to be, I don't even know how you would biohack. Is it sort of eating an extra number of eggs at a certain time of the month to increase your cycle? Anything like that, I haven't even steered into that land of having a read.
Yeah, well, I mean, this is why we're talking about it, because, like I say, there are people out there that specialize in hormone optimization. And I'm like, that's an interesting phrase, because the only expert in hormone optimization is our own our own bodies and homeostasis and all that stuff. Maybe we could just talk about the regulation of hormones, again, it's this idea of understanding. I mean, I talk about things like limits of knowledge, ignorance of one's ignorance on these sorts of topics, and I think, to understand just how complex this process is, which of course would be, years of study in itself rather than a 1 or 2 hour podcast, but just give us a peek through the window of the complexity.
Oh, it's so complex. And even that's when you're sort of asking me this question. I don't know if I'm even feeling in a position to be able to answer it, because we know the body is acting always to maintain homeostasis. So if we think of something like stress, whether it's physiological or psychological, it can have an impact on the menstrual cycle, whether it's shortening the number of days of that menstrual cycle, elongating the number of days. We talked a little bit about nutritional stress before, lowering these hormone concentrations and, potentially in the future leading to amenorrhea. So it's acting always to maintain homeostasis the best it can. So in terms of the nutritional defect, it's really trying to preserve energy for other more essential functions, like making sure your heart remains beating. So there's always going to be a give and take on why the body starts changing things. And it's about understanding that you don't need to biohack the hormones to do it. It's about understanding what the stress is, what the reasons behind changes are. It's where monitoring and looking not so much at trying to make the body do something in particular, but identifying changes, it can be really important.
Yeah. And I just want to clarify that, I mean, look, the context here is from, apparently healthy people, as doctors like to say, apparently healthy. I love that phrase. But it's not clinical stuff. Of course, there are people that will have problems that absolutely would require an endocrinologist or whatever support, medical pharmaceutical support. But we're talking about people who are physically active, they're athletes, recreational athletes. There's nothing particularly wrong with them, but they are interested in optimizing their health, optimizing performance, optimizing body composition. And from that perspective, as far as we know, as far as the evidence tells us, that's what the body is very good at regulating and managing. We are here to support that, which is why we eat, why we drink, why we breathe, that sort of thing. But since we're talking about nutrition as our main sort of focus here, how does nutrition impact the hormones? We know that a drug, a prescription, you can take something that can have an impact on your hormones. A certain event, like an extreme level of stress, for example, or, there are various things that can disrupt our hormones. Absolutely. How does food get involved in this situation, though?
I'm not sure food really does affect the hormones per se. I haven't seen anything scientifically that says we should be eating at certain times of the menstrual cycle to optimize, the way we respond to food. I don't see anything that says that eating, I'm going to say bananas just as an example, eating bananas is going to do something to the hormones per se. In terms of differences between men and women, I definitely think a lot of our guidelines for nutritional intake have been based on men. So we've, as a research group, done a lot of audits recently looking at Megan Kirkman, for example, looked at carbohydrate intake in its acute and chronic sense, and found that when she looked at the literature that informs our current guidelines, it was about 10% of that literature was actually done in females. And if you look at how much of that actually controlled for the hormones and really took that into account, it was next to none. And same, another PhD student, Ella Smith of ours, she looked at the performance supplements and also the medical supplements that we use with athletes. And again, she saw such a small amount of the literature was actually made up of females. And therefore, we don't really know what the effects of nutrition and hormones are because we haven't looked at it in enough detail to make any bold claims at this point.
Can you throw out any sort of rough percentages when we're talking about proportion of males and females? What, if you had to guess, roughly what would it be?
In terms of the literature's representation at this point? Yeah, it was about the 10% mark for the carbohydrate-based study. So 10% were female, 90% were men. And I think in the case of the performance supplements, that might have increased to 15% off the top of my head. The one that was quite surprising was maybe the medical supplements. We do see the representation of women a lot higher, and that has to be, well, I should note that was driven primarily by pregnant women. We do a lot of research into pregnant women and maybe nutritional or medical supplements that may support pregnant women. But that is sort of the exception to what we've found so far across some of these audits, where really the majority of the research that has been done on men, and that has informed our guidelines currently for women.
So when when we learn about physiology, biology, and so on, we understand that there is a process in the manufacture, if you like, of these various hormones, and the body has certain requirements, which is why we eat food. We breathe, we drink, and so on, to provide the body with the raw materials with which to manufacture these hormones. And let's spend less time now talking about how the body actually regulates and manages hormonal status. It's quite clear that there's quite a lot known generally about how these hormones work mechanistically. And we've also made it clear, or you've made it clear, there's really nothing out there to suggest that certain types of eating, etc., will have, say, disruptive influences of any major significance over the course of a day, a week, a year, or whatever. But nonetheless, the way we approach our diets, which varies massively from individual to individual, personal preference, fads, practical reasons, religious reasons, and so on, which may result in certain substances not being available in their diet or in sufficient quantities. Do you want to just delve into that area? Because that, of course, is an area where there is some evidence and an area that you yourself have done research on.
Yeah, I think the biggest one that has evidence to suggest that the body requires differences in micronutrients between men and women is iron, so dietary iron. In terms of women, we know that they, typically, I will say typical women, eumenoric women undergo menstruation, and that's a direct loss of iron through the blood every month, and that's going to provide a significant challenge to iron homeostasis. We also know, going back to the hormones really briefly, that there is some evidence to suggest that these can help regulate one of our iron regulatory hormones, hepcidin, and therefore we may see differences in absorption even across the cycle. We need more evidence and more research to confirm this, but that's our speculation at this point. So because women are having higher iron turnover and higher iron losses, they do require more iron for the body to maintain homeostasis, and iron can't be made by the body. It can only be obtained exogenously. And so for the dietary iron requirements and recommendations at this point do suggest that men only require about 8 milligrams of iron per day, and women require 18 milligrams of iron per day to account for that additional loss that's occurring each month and potentially the changes in absorption across the cycle.
Should there be an assumption that if you're a female and you're an athlete, for example, and by athlete, somebody who exercises a lot, let's just leave it at that, then there's a particularly high risk of a problem with iron? And if so, how are they going to know that they've even got an issue with an iron insufficiency or even a deficiency?
Yeah, I think when we talk about high risk groups for iron deficiency, we typically say women as a first step, and that's a high risk group being half of our population, but premenopausal women. Endurance athletes, we think the repetitive nature of endurance exercise, and particularly on legs, running, can be a significant challenge to iron homeostasis. And then the third at-risk group we say is vegetarians or vegans who are removing some of those animal-based products from their diet, which are often rich in heme iron, which is our most bioavailable iron source. And so that removal can potentially limit the amount of iron that's going in to be absorbed. So we say they're our high-risk groups, and you're absolutely right. If you have a female vegan runner, it's a bit of a recipe for disaster in terms of ensuring they're getting enough iron in. And I should also say those numbers that I just mentioned are really based on the general population. We still don't have these numbers for athletes. We still don't know what the difference in iron turnover or quantified the difference in iron turnover between the general population and athletes, and that's something we're doing at the moment. But it's likely those numbers are even higher for athletes that have these direct iron losses that are occurring during exercise, as well as some malabsorption that's occurring in the hours following exercise due to some hormonal fluctuations.
So look, everyone's heard of iron. They've even got an idea that, it maybe has an impact on, red blood cell formation and impacts things like oxygen carrying capacity and so on. But maybe they don't. I don't know. But there's an awful lot more to it than that. And since you are an expert, particularly on this topic, let's just hang around this segment for a second about iron. I mean, why is it important? Not just for basic health purposes, but for people who do want to optimize their health, their performance, get the most out of their adaptations to training, and ultimately on competition day or game day or whatever, be at their very best. What's iron got to do with all of that?
Yeah, I think there's probably 4 key parts or 4 key roles that iron can play. The first one is it forms the key part of our red blood cell, which is called hemoglobin. And hemoglobin is responsible for carrying oxygen around the body. And that's directly related to our VO2 max or our aerobic capacity. So when we're low on iron, we become low on hemoglobin, and that affects our VO2 max and our aerobic capacity. Another function of low iron is that iron's required in the muscle. It's required at the electron transport chain to make ATP or to make energy. And if you're low on iron and there's not enough iron within that electron transport chain, you may become more mechanically inefficient. You may not be producing energy as well, and that's going to affect your performance directly. We also know, though, that iron's really important for the immune system. So if you have iron that's too low as well as iron that's too high, you may be at risk of illness more frequently because iron's sort of been sequestering in the cell. And there's a whole evolutionary chain to why we do that. But essentially, it may affect your training availability, which isn't good for optimal performance. And then finally, we also know that iron has important roles in the brain and for cognitive function. To be honest, in terms of athlete performance, this is really hard to measure, and we haven't got a lot of athlete information on this. But based on what we do know about the biology, it could be inferred that iron deficiency may impact cognitive functioning during sports, and this may be applicable for team sports where decision making is really important. Iron deficiency may be impairing your decisions on game day.
So, of course, we're focusing also here not just on iron in this particular segment, but also on females and issues they have with iron. And there are various reasons that spring to mind beyond there being an athlete that you've discussed, and that potentially increasing their iron requirements. But being a female alone also has an interesting relationship with iron needs. What's going on there?
Yeah, so as I mentioned, when we're menstruating, we are losing a significant amount of iron, and that in itself is meaning the body is sort of lowering its hepcidin levels to try and absorb more iron. It's trying to encourage more iron absorption to occur to replace those losses. So we see an inherent loss and requirement for more iron just from biologically being a female. As I also said, that there's changes in estrogen and progesterone, which may influence the amount of iron we're absorbing across that menstrual cycle. So there's that influence as well. We also think that females, and this is really difficult to quantify because I think low energy availability has been a female issue in terms of its origins in the female athlete triad. But typically we associate low energy availability or a higher prevalence of low energy availability with female athletes. Whether this is true or not is probably because we don't have the best tools as of yet to get some good data on whether low energy availability actually differs between sexes. But typically there's been a lot of research around low energy availability in females, potentially under eating in females, and therefore if you are not eating enough calories to meet your daily requirements and the overall pool of energy is shrinking, then the overall amount of micronutrients is shrinking as well. And so that's not just applicable to iron, but applicable to all sorts of other micronutrients. But essentially that means that your diet is smaller, yet you're requiring, in the case of iron, more iron than a male. So your diet has to be so nutrient rich if you're either an athlete that's needing to limit your food intake for weight sensitive purposes in terms of being in an aesthetic sport or a weight controlled sport. But if you're also just maybe not aware that you're under eating, you're also not only just under eating in terms of calories, you're probably under eating in terms of micronutrients, which is almost a doubly compounded problem when we think of things like iron.
Yeah. And that, I mean, this is an interesting area, relative energy deficiency generally. So much so, actually, I have Dr. Margot Mountjoy is coming on in a few weeks from now. Maybe not when I release the podcast. I've got to not confuse the listeners, but I'm recording this in a few weeks' time, who is the lead author on the IOC consensus statement on this very topic. And it is really interesting for anyone who, not just females, by the way, this also affects men, but simply a situation where athletes or people concerned with their physique are consuming less food to, either by design and or as a result of all their training. One way or the other, they are in an energy deficit, which, as you know, simplistically, you're just eating less food, which of course means you're getting less nutrients, as you've already pointed out. But that situation is extremely common in the athlete sphere, particularly elite athlete sphere, particularly female elite athlete sphere. I don't want to spend too much time on energy availability as a general concept, because I will, as I say, do a podcast on that. But since we're there, you've described this situation where people are either deliberately or whatever, they are under eating, shall we say. They're eating a potential insufficiency of energy, but it's not just energy because they eat food. And with that energy is packaged micronutrients, not just iron. And we're going to come back to iron in a minute. But what other micronutrients then are going to also be sort of part of this sort of collateral damage situation that's occurring?
Yeah, I think the big one that we've maybe looked at a little bit more is calcium. So we know calcium is really important for bone health, essentially. And when we're exercising, we see drops in calcium. We lose calcium through our sweat. And if you compound that with low dietary calcium, what the bone actually does is the bone breaks down to release calcium. And calcium homeostasis is incredibly tightly controlled in the body. It's required for all our muscle contractions. So the bone is seen as a sacrificial organ, if you will, to make sure that calcium homeostasis remains really tight. But that breakdown of the bone is really not a good thing for athletes. So we have peak bone mass by the age of 30. And from that point on, it's all downhill. So particularly adolescent athletes or athletes in their 20s that are having increased bone breakdown to release calcium, they're almost fast-tracking their development towards osteoporosis later in life. So we don't want to be seeing that. And calcium is a really big one when it comes to potentially not consuming enough because of low energy availability scenarios or dietary restriction. So calcium's a big one for us. The other micronutrients we focused on in a recent review, we looked at vitamin D as well. Vitamin D is primarily environmental, or you obtain it from the environment, but it can affect and promote calcium absorption. So you need sort of calcium and vitamin D hand in hand. And then finally, folate's another big one that we like to see enough of in the diet as well.
So when, again, with our sort of lens of not just athletes, but female athletes, some of these nutrients stand out a little bit more than others, though, don't they? I mean, so for example, the reasons why you might be calcium insufficient or indeed vitamin D insufficient might be due to a lack of dietary intake and or exposure to sunshine, and we'll be doing something on vitamin D in the near future as well. But it seems to me that the iron situation is particularly problematic for females, right, for reasons that you've already explained. But you've also mentioned folate, and that makes me think also of pregnant females that are either thinking about or currently are on their way to having a wonderful child. What's going on there, and what's relevant about that to females and, of course, performance and stuff like that?
Yeah, so when we wrote this review, I dived into folate. That was sort of one of the nutrients I was given to have a look at. And I hadn't done a lot, but it has links with iron. You know, they're both related to red blood cell production. So I thought, you know, this will be nice and easy to have a look for. And outside of the pregnancy literature in terms of females, there was next to none. And if you're talking about pregnant athlete literature, there was zero. So we typically say that a healthy woman requires about 400 dietary equivalents of folate a day, and this increases to about 600 in pregnant women. And this is simply because the blood volume's expanding. You're needing to create new red blood cells for not only yourself, but to support a child as well. And so you need to have enough folate going into the system to be able to ensure that you can create those red blood cells. And we do know that fetal outcomes are not great when you haven't got that folate in, particularly early in pregnancy. So it's a really essential micronutrient in terms of pregnant women. In athletes, we don't really know much more than that, though, unfortunately, at this point. You know, you can only imagine that not only are they trying to create red blood cells to support a fetus, but they're also trying to do it to support their aerobic capacity and their ability to train and perform at the higher level, still probably in the early stages of their pregnancy. So that demand could be much higher. We don't know yet. I think the big thing we came to the conclusion around was that most dietary supplements do come in doses of around 800 to 1,000 dietary equivalents, and therefore that's probably sufficient for an athlete as well. We think that sort of has enough buffer. And certain countries, not all countries, but a lot of things like cereals and breads and other common items are now fortified with folic acid, which is really good in terms of trying to increase folate in the diet inherently across the lifespan. So, yeah, that's where we are at with folate and athletes. We don't know a lot. We don't see a lot of deficiencies, but we probably also don't test for a lot of deficiencies, and that's probably why we don't see them too.
Yeah, they bring me on to the concept of test, don't guess. And look, it's not something that everyone's able to do. It's a bit tricky. Some countries also have restrictions on what you can and cannot test for. But once again, it will also come down to, I mean, there's also variations in quality of testing. You can go sort of finger prick via the post, via mail, or go to a clinic and have a proper blood draw. But even then, there's going to be variations on labs, different reference ranges. I mean, it's all quite messy. How do you think this should be approached? Because you did mention about supplements. We'll come to that in a minute, because obviously people are going to be thinking, I'll just take a supplement, but how do you even know that you are insufficient or deficient in these things? Let's get into that for a bit.
Yeah, I think screening's a really critical piece, and I know it's expensive, and I know not all athletes are going to have the means to be able to screen for all things all the time. A few years ago, we put together a framework which was led by Mark Sim, looking at the frequency of screening for iron deficiency specifically. We suggested that you can use the assumption that you should have an annual screening unless you're a female, and therefore you then need a biannual screening, so twice a year. And then on top of that, if you're a female that has risk factors such as potentially REDS or history of iron deficiency or menstrual irregularities, dietary issues in terms of, I shouldn't call it an issue, but maybe dietary risks such as vegan or vegetarian diets, poor training quality recently, those things may prompt additional testing, and we think they may need to be screened quarterly, so maybe every 3 months.
Okay.
In terms of other micronutrients, they may not need to be screened as regularly. They may not change as quickly. We see iron in some of our studies drop by about 45% over the course of just 3 weeks of really heavy training. So it can drop really quickly, and that's why it needs to be measured more frequently. But I think if you are somebody that's maybe not at risk, you haven't had a history, you can extend that out, and that can be an annual screening, and that might include some of your other nutrients as well.
Yeah, well, but I mean, my own experience in this is 100%. I've seen, as you have suggested, the need to assess or screen my clients, my athletes on a pretty regular basis. It's actually quite surprising how much rates of sort of repletion, if we call it, when you do discover that an individual is insufficient or even deficient, particularly with iron. How long it can actually take to rectify these situations. Have you got any thoughts on that, just to help people understand? It's not just a case of, say, eating a steak and then all is fixed for iron, and or a supplement to solve your folate issues. What do you know about that?
Yeah, in terms of iron, at least we typically say iron deficiency has 3 stages. And we like to do that because what it means is that if you can pick up an iron deficiency in the first stage of iron deficiency, it's going to be quite easy to correct and quite easy to get it back to a stage which we would consider sufficient, and doesn't probably require a lot of effort to get it back to that point. You could even do that with a dietary consult. But when we're talking about stage 2 and at the worst case scenario for iron deficiency, stage 3, iron deficiency anemia, we know that takes significant intervention. And we like to look at oral iron supplements as a treatment strategy there, and we know that takes about 12 weeks to be effective. And the lower you are, the longer you're probably going to have to supplement to get up to a level that we're happy with. We do know there's ways you can bypass that time frame in terms of intravenous iron injections, but they come with a set of risks that you need to accept or need to consider if you're going to go down that path. In terms of folate, again, I think there is a similar time frame. We're talking about the development of a red blood cell, ensuring that it has all the requirements in order to do that. And calcium as well. It's about constant calcium availability. I think we're talking about changes to the homeostatic mechanism. So you could have great calcium one day, but if the other 6 days of the week aren't there, you're going to see that sort of same action of the low calcium on the bone. So it's about consistent quality in those instances, I think.
So, you've mentioned iron, you've mentioned calcium, we've mentioned supplements. People are going to go, right, I recognize some of these situations. I deliberately eat, in a way that might result in an energy deficit. I'm trying to sort out my body composition. I'm an elite endurance athlete. It's hard to eat enough food sometimes in those situations, but I'm just going to solve the problem by taking a supplement. That's just an easy one. And I'm just going to whack in some iron and whack in some calcium. What are your thoughts and concerns about that strategy?
Yeah, there's probably a few concerns that come to mind. So the first one, when we're talking about I probably need a bit of this and a bit of that, we're talking about multivitamins. And there are some good multivitamins, don't get me wrong, but you need to know what's in your multivitamins. So a lot of the times they go, oh, that has calcium on the label somewhere. It may have such small amounts that it's not doing anything. And it may also have other things that you don't need. It may also be a wider doping risk, and you always need to be really sure what you're taking. And that approach of just, oh, but I take something and you don't know exactly what that is and exactly why you're taking it, puts a flag in terms of potential contamination risks for me. So that's probably my biggest concern. But my second concern is more around, again, back to the iron, around something like iron toxicity. So we do know a lot of athletes have hemochromatosis. It's a condition of excess iron storage. It doesn't manifest until in men, normally late 40s, 50s, in terms of excessive iron being stored in the liver. And if you have this condition and you don't know, and you're essentially storing up on iron, you may be putting yourself at a health risk. And so I think you shouldn't just be supplementing without knowing where your iron stores are at. You want to know if you're a deficient, and if you are deficient, you can correct that deficiency really easily with supplements, and there are really effective means when taken appropriately. But this idea of just supplementing and not knowing where your iron stores at, you could be putting yourself at risk of iron toxicity. And yeah, it's a small risk in terms of the proportion of people that may have hemochromatosis, but it's a significant enough one that you don't want to be doing yourself more harm than good.
Is there a situation where, and I'm talking supplements more than food, just because of the high levels, the sort of the super physiological levels, if we were talking about hormones, I guess, but the levels that you do not find present in food, it's much more, which we find in high dose supplements and all those sorts of things. Can there be any competitive natures between, I'm talking about nutrient interactions, that sort of thing? Is there any concerns there?
Yeah, I think the biggest one we know of is the iron and calcium interaction. So to be honest, we actually don't know a lot about why this is the case, but we do know that when iron is co-ingested with calcium, that you will have a lower amount of iron absorption. And we think this is something around competing for receptors around absorption. They're sort of on the similar receptors, but what we do know, and it's the same thing, if you're taking an iron supplement and eating a big bowl of Wheat Bix, I don't know if that's an Australian reference now I say it, but Wheat Bix with milk, you're lowering the amount of iron that you're going to take from that meal or that supplement because you're co-ingesting it with calcium. So we do typically say if you are requiring both of those supplements, again, it's knowing that you do require both of those supplements, and then it might be that you take your iron in the morning and then your calcium in the evening to stop that competition over absorption occurring.
So obviously, look, we've discussed all sorts of things here about female athletes, some of the things that distinguish males from females, some of the complexities that female biology throws into not just research, but, this stuff about nutrition and how we can influence it through diet and supplements and so on. Now, it is pretty complicated. It's not something that is that easy for an individual to sort out for themselves. We obviously would advocate that individuals would go and consult with an expert, a suitably qualified expert, a sports dietitian or a registered sports nutritionist, for example, or a medical doctor, of course, but who has particular expertise in active athletes and so on. So, that goes without saying. However, the listeners are still chomping at the bit for some practical advice and recommendations, just as a sort of as we get to the end of this conversation, as a sort of an overview of some practical advice and recommendations for our female listeners or for our males that are working with or in one way or the other support female athletes and active individuals. What do you have to say?
Yeah, I think a food-first approach is always a nice way, and I know that's maybe the boring answer to give for somebody that wants a quick fix about how they can improve their diet. But it's really about looking at quality food sources that do have high nutrient value. So the example I always give is leafy green vegetables, something like Chinese cabbages, spinaches. They pretty much have every micronutrient under the sun in them that you'd want in terms of particularly iron, folate, even vitamin D's in there. So those sort of vegetables and fruits are really your first stop at trying to improve your dietary quality and therefore your micronutrient status. I would also say that, again, I know we said try not to go to recommend sports dietitians, but they're so useful. And if you are going to invest in supplements and spend the money, because they're not cheap, if you're going to spend the money on your supplements, I would also spend the money on seeing a dietitian to advise around how you can get the best out of your supplement and whether you need it at all or whether you could potentially do with a different supplement. So I think firstly, increasing those vegetables in the diet, getting better bang for buck in terms of what you're eating, in terms of your micronutrients. And then if you're going to go down the supplement route, and I'm an advocate of supplements, I think there's a place and a time for supplements and they just need to be taken with good advice and not just money down the drain.
Well, we have, I've already recorded this conversation with Professor Graham Close all about food first, but not food only. That actually may come out after this particular podcast, but nonetheless, it's gonna be there, and it's a fascinating topic in itself, and it's very much this strategic use of these tools and strategies that we have in sports nutrition, clinical nutrition, etc. But they need to be well chosen strategies. Sometimes you're not equipped to understand whether it's a well chosen strategy or a pointless strategy, or indeed a dangerous strategy. There are various scenarios that can occur there, so it is best to seek qualified help and support. But of course, we're trying to help people with their knowledge on this stuff through this podcast, Alannah, and you've really helped us in this particular topic. So I'm going to ask you to just briefly summarize then this thing that we've been talking about, micronutrient considerations for the female athlete. Do you have sort of a little summary for us on this topic?
Yeah, I think it's worth noting that males and females are different, and whether it's as simplistically as their body size or more physiologically in depth as their hormone fluctuations, they are different. But if there's any evidence, I should say there is no evidence at this point to suggest that we need to be tailoring our diets differently for men and women, and even less evidence that it should be different for the menstrual cycle. We know that there are key micronutrients that do differ between men and women, and key targets, but that doesn't mean that we should be starting to change our diet based on the menstrual cycle whatsoever. Those key targets really are iron. It's probably one of the few where we do know women require a significantly greater amount of iron than men. We also know calcium intake is really good to maintain bone health, and we should be prioritizing calcium intake in women, particularly knowing the interactions with estrogen and bone as well. We know women in their 50s are at really high risk of osteoporosis generally, and if you're not supporting that bone earlier in life, you're fast-tracking your way to that condition. Vitamin D is really important to help that calcium absorb, so try and get a bit of vitamin D in the diet. And folate's really a bit of an unknown area if we talk about athletes specifically, but typically pregnant athletes, we need to be really taking care of their folate requirements and understanding they might be even higher than just in pregnancy.
Dr. Alannah McKay, thank you so much for joining me on Fueling Greatness and sharing your knowledge and experience born out of research on this topic. I know this is an evolving field, an evolving area, as you've made very clear, and I really hope to have another chat with you down the line when you've done more research and you've discovered a bit more, and we can continue this conversation further.
Yeah, absolutely. And thank you so much for having me.
It's been a pleasure. Thank you so much.